Hello everybody, welcome back to Algebra 2. Here is your bell ringer. So please have the sub pause the video and work through the bell ringer. You guys should be able to talk through this at your tables. Alright, looking at this, it's absolute value. We haven't done any absolute value yet. We're going to go through a couple today, and I'll bring some back on Wednesday or Thursday. But if you remember absolute value, what do the absolute value brackets do to everything? It makes all negatives positive, okay? So anytime you see a negative inside the absolute value after you plug stuff in and simplify, then it would make that number positive. All right, so when we're looking at these, I have x equals 1.5 and y equals 4. We're just going to substitute those into our expression here. So 2 times 1.5 plus 4, okay, just substituting in. And I like to put anything that I substitute into an equation, I like to put it into parentheses just because I know that I've substituted in there. Okay, so multiplying here, so 2 times 1.5, that would give you 3. Okay, you can use your calculator, or you know that 1/2 or 1.5 is 3/2. So 2 times 3/2 would give you 3 plus 4. That's inside my absolute value bracket. So 3 plus 4 give me absolute value of 7, and we know that that's just 7 because it makes everything positive. Okay, plugging into the second one here. So we have 5 times the absolute value of x, which is 1.5, times y, which is 4. Okay, and then minus a w, which is a -2. So it looks like our absolute value brackets aren't really going to change a whole lot with this one also. Okay, 1.5 times 4, that gives me 6. And then a double negative here, so that turns into a positive. So we have 6 plus 2, which is 8 inside of our absolute value brackets. We have 5 times the absolute value of 8, which is just 5 times 8, which is 40. All right, so there's your bell ringer. Okay, now you guys need to take a few minutes to look over your homework. You guys can talk about the homework, give you about 5 to 8 minutes. Talk about the homework, make sure you guys got everything correct. You can compare stuff, or I have the book in front. You can look at your answers in the book. All right, when you are done, when the 5 to 8 minutes are up, please turn it into the yellow bin up front. All right, so please pause the video and do that now. Okay, starting with some notes. I skipped over this stuff yesterday. I'm going to use these two examples here. So I'll call this example A, and I'll call this example B. Okay, and we're going to use these two examples to kind of do absolute value here. This is kind of a lot in 2 problems, but I'm going to talk through it, and I'll talk through it again on Wednesday or Thursday when we look at absolute value equations again. All right, so looking at A here, so if you guys remember what the definition of absolute value is, you probably don't. That's why we're saying this here. So if I say x equals absolute value of 5, okay, then we'll say it the other way around. Absolute value of x equals 5. Let's do it that way. Absolute value of x equals 5. All right, so you know that 5 would be one of the answers, because if I put a 5 inside of the absolute value, I'm going to get a 5. Okay, you could also throw a -5 into those absolute value brackets, because absolute value of a -5 is just a 5. So absolute value is the distance from 0. Okay, so we're saying this right here would be the distance from 0, and we're saying that that is going to be a 5. So that means I can go 5 to the right here, so I'd have a dot there, or I can go 5 to the left of 0, which is a -5. Okay, because distance is always positive, but distance is just measured in units. So I'm going 5 units here, and I'm going 5 units here. So absolute value can be either to the right of 0 or to the left of 0, just because the way it's measured is distance. So I'm thinking this first problem here, I have the absolute value of 4x minus 1 equals 2x plus 9. So I can use this equation as it is right here, because this would be considered my positive distance, or I guess not positive distance, my positive side of the absolute value. Now we also need the negative side of the absolute value. So I would take both of these numbers right here and change their signs, or I would just multiply the whole thing by a -1. So it would look like this. I have 4x minus 1 equals -2x minus 9. So this one up here, that's going to be my equation that would represent the right side of 0 to the right of 0. And then this one right here would be what would be represented by my left of 0, or my negative, okay? So you have to make two equations when you're solving absolute value equations, because you can have to the right of 0 or to the left of 0. So once we have the two equations, go ahead and solve them for x, all right? So solving these for x, it's pretty much the same steps on both of them. You want to move the variable to the same side, so up here on the top I move the 2x to the left. I'm going to move this guy down a little bit so it's out of the way. 4x minus 2x, that gives me a 2x, and I'll just move that 1 over in the same step. Alright, so I get 2x equals 10. Pretty quick here, divide by 2, I get x equals 5. That's one of my answers. So since we have distance to the right of 0, distance to the left of 0, we have two answers, okay? Because we could have the right, which is positive, the left, which is negative. Alright, so same kind of deal on the second one here. So add 2x, so that's different a little bit. That gives us 6x, and I'm going to add that 1 to both sides. So I have 6x equals negative 8. Divide by 6, and I get x equals, it would be negative 8 over 6, but we got to reduce that. So you take a 2 out of the top and the bottom, like that. So it's 4/3. It's negative 4/3. Okay, so if I would use these two answers I got, plotting it on this graph that I have up here, I got x equals 5, so this is the blue ink. That's one answer, then x equals negative 4/3, so that's negative 1 1/3. That would be how I graph those if it's just equal sign. Okay, it's not an inequality. All right, so that is just the equation. So now with inequalities, so this one here, inequalities, if we think of our number line, all right, so we'll just use the greater than or equal to 10 that's on there. So I'll say I got 10 there, and I have a negative 10 because we're doing absolute values, so we can have right of 0 or left of 0. How do I graph greater than or equal to 10? Well, I know that it's going to be a filled-in circle, and greater than or equal to is going to the right. Okay? If I have this one going to the right, so it's going right of 10 because it's greater than or equal to, I know that it's going to be going the opposite direction for the other side. So I'll also have less than or equal to negative 10. Okay, and I kind of do squiggly lines so you can see it a little bit better. But I have to make an equation for that, which is what I have already. Okay, that's this one. That's my first equation. And then I have to make an equation for that, which is the negative 10. So I would rewrite this, 3x plus 5. And how do I write to represent that? So that's going left of negative 10, so that's less than or equal to negative 10. So when you make these two equations, all right, for your positive equation, you're going to have a positive 10. For your negative equation, you'll have a negative 10. But you can see that you change the signs. Positive equation, I keep the sign the way it is. Negative equation, I flip the sign. Okay? So those are the things that change when you're doing inequalities. So once you have your two equations set up, go ahead and solve that like you would a normal inequality. Okay? So steps here, just like before, are pretty much the same. Okay, so minus 5, I got 3x is greater than or equal to 5, divided by 3, that x is greater than or equal to 5/3. Okay, that's one answer. We need the other answer now. All right, minus 5, so we get a little bit different answer here. 3x is less than or equal to negative 15. Divide by 3, we get x is less than or equal to negative 5. All right, so putting these on a number line. So we always have to put 0 there, just so you know where 0 is. 5/3, so I'll draw some tick marks here. So we have greater than or equal to 5/3. So 5/3, that's like 1 2/3, so we're in there-ish. And it is filled in because it's equal to, so we're going to the right of there. We use different ink. Okay, so 5/3 right there, going to the right. And then we also have a -5 going to the left. So we're here and going to the left. So that's how I would graph that. Okay. One thing that I am kind of particular about on these is you have to know if it's an or an and inequality. All right. If it is an or inequality, like this one, you know that they're going to be going different directions. All right. So ors are going to always look like this. Okay. This is an or. And inequalities, or what are often called compound inequalities, those are the ones that are kind of like dot here, then everything filled in between. These are and inequalities. Okay? If you got arrows pointing in the opposite direction, they are ors. So that means this is an or inequality. Okay? And a way you can tell by looking at it right away, you have a greater than sign. You can say it's greater. Okay, greater than. So if it's greater than, you know it's going to be an or inequality. Okay, so those are the review problems. I'll probably give you guys some more of those on Wednesday and Thursday. All right, so those are the absolute value inequalities and equations. Okay, on to chapter 1.4. Okay, so 1.4b is writing linear equations and graphing linear equations or inequalities and equations. 1.4b is a continuation of what we did yesterday, and 1.5 is just graphing linear inequalities. The book assumes that you already know how to graph equations, which you guys did in geometry or intermediate algebra, but I'll do a quick review when we start graphing those. Okay. If you remember the lines where you graphed them and they were either dashed or solid and then you had to shade above or below, that's the graphing linear inequality. All right? So write down your title, and then we will get going. All right, so the next thing in our linear equations were standard form. That was standard form that's on the wall above the board where I showed you guys yesterday. So you have ax plus by equals c, all right? And now a lot of people get confused by this because they're like, oh, how do I solve for a? How do I solve for b? Or how do I solve for c? Whenever you see like letters in succession like that, you got a, b, c, d, e, f, g, those are just placeholders. So you're not actually solving for one of those. Whatever number falls in that place, that's the number for A, that's the number for B, that's the number for C. So you're not going to be solving for those. That's a common mistake. Okay? So there are rules with standard form equations, and I'm not sure if you guys had to follow all of these in your Algebra 1. I know you did in intermediate, but to get an equation in standard form, you need to follow these steps, all right? So you're going to be given equations, and you're going to have to rearrange them to look like this. So x and y have to be on the same side of the equal sign. So that means I have an x and a y on the left. That's where they're going to be. So if you're given y equals mx plus b, all you have to do is move that x term over. Okay? X is the first term. Okay? X is first, and a is positive. All right? So that means if you move your mx over, so if you move that x term over to the left, if it's negative, how do you take care of that if it's a negative? You have to multiply everything by a -1, okay? So, may need to multiply by a -1 to fix it. All right? And then the third thing here, no fractions. All right? I showed you guys yesterday in an example how to get rid of fractions. If you don't remember, you can multiply by the common denominator. That's how you get rid of fractions. Okay, you're going to multiply by that common denominator and make sure you distribute it through everything, and that should help you get rid of all the fractions. Okay? So those are your steps to getting standard form equations. All right, so let's try a couple here. So we want to change these three equations to standard form. So go ahead and write these three down, and then we'll work through them. So please pause the video and let the kids write through it. All right, so looking at number 1 here, so we have 7y minus 5x equals 2/3. So we got a couple things, or a couple rules being broken here. X is not first, so that's the first thing that we can look at. So all we have to do, we can switch these two around by commutative property, but remember, if you see a negative in front of a number or a subtraction sign like that, that is a negative. So when you flip it around, that negative has to tag along with it, or tag along with it. So it's negative 5x plus 7y equals 2/3. Okay? So next rule we have to fix. We have our x first, that's good. Now we have a negative out front. And we can really do two rules at once here because we got the negative that we need to fix, and we have the 2/3 that we have to get rid of because we cannot have a fraction. All right, so the thing that we need to do is multiply by a -1, okay, and we're going to have to multiply by a 3 to get rid of that 2/3. So let's just do it all at once, and let's multiply everything by a -3. Okay, distribute a -3 into everything. All right, so remember, if I'm distributing that into here, I'll write it out at each one. So we have -3 times -5x plus -3 times 7y equals -3 times 2/3. Okay, this is the one where people probably get lost at. How do I multiply those fractions? Okay, so these right here, that gives me a 15x. Right here, that gives me a -21. Okay, I don't need that plus since I have a negative already. So -21y, and then here, multiplying the fractions. So this is like 3/1. Remember, if we multiply, the first thing you look for is cross-canceling. So what does that cross-cancel to? The 3's are gone, and I have a -2. And that's it. That's all you have to do for that one. Okay? We can have a negative in there. We have the -2. Okay, the area where we cannot have a negative is out front, which is positive here, so we're good. All right, working through the other ones. So right here, number 2, I know that I'm going to have to take this and move it over. Okay, so I have add 1/2 x to both sides. So I have 1/2 x plus y equals 3. All right, so we see a fraction, multiply everything by a common denominator, which would be multiplying everything by 2. And then you're done after that. All right, 2 times 1/2, that's just a 1. So you can write 1x if you want to, or you can just write an x, that's okay. All right, so now we got the y, so plus 2y, and then we have the 2 times the 3, so that's equals 6. That's done. No negatives out front, no fractions, we got the x first. Okay, last one down here. So a couple things we're going to have to do here. We don't want any constants on the left, okay, and we want the x over to the other side. So these are the two things that we have to move. All right, so subtract 1, and then subtract 1/2 x, subtract 1/2 x. So if I rewrite that, I have -1/2 x because I want to write the x first, plus y, and then I have -2 minus 1, so that's -3. Okay, so think about what we're going to have to multiply this thing by to get rid of the 1/2 and the negative. I'm going to take it all times a -2. Okay, because if I multiply a -2 times -1/2 x, fractions are gone and I get a positive. So I have 1x, positive 1x, minus 2y equals 6. Okay, and then you're done. X is first, x is positive, no fractions, good to go. Okay, so really, you're not solving for A, B, or C. You're just looking at it and trying to rearrange it following those rules that we had before. So A, B, and C stand for placeholders where the numbers are. So here A would be 15, B would be 21, C would be -2, but it doesn't really matter because you don't use them in any kind of computation or any kind of calculating to figure out anything. Okay, so that's standard form. All right, so yesterday we covered slope-intercept form. That's y equals mx plus b. Remember, m is slope, b is y-intercept. You shouldn't have to write these down because you should have them down already, so you can reference these in the next example. So look at your notes from yesterday. All right, and then we have point slope form, which is right here. And if you can't see it, I'll write it out again. So it's y minus y1 equals mx minus x1. So you need a point and a slope for that one. Okay, we know the x1 and the y1 are my coordinates for the point, and the m is the slope. And if you forgot slope formula, which I hope you didn't, because you had to use it on the homework, that is slope formula. y2 minus y1 over x2 minus x1. So change in the x's or change in the y's, or rise over run if you're looking at a picture or a graph. All right? So we are going to use these forms to do the following. We want to write an equation of a line going through 2, -3 and -3, 7. We're going to write the equation in all three forms. So we have slope, intercept, point slope, and standard form. Okay? So please pause the video and let kids work through this, see if they can get it in all three forms. All right, back to the work. So point slope would probably be the easiest in my mind because I told you guys yesterday, point slope was the easiest to change it from one form to the next. Okay? You could have done it the way where you take the 2 points, find the slope, then use one of the points to find the y-intercept if we're solving for slope-intercept here. But in my mind, it's easier to do point slope first. Okay? Because really the only thing I need to do for point slope here is find my slope, and then I just use one of the points and I got it. Okay? So let's calculate slope first. All right, so using this point and this point, we do y2 minus y1. So it's 7 minus a -3. Remember, you got to be careful with these negatives. So it's y2 minus y1, so that's a double negative there, over x2, so it's -3 minus x1. All right, so double negative there. You got 10 over -5, which simplifies down to a -2. That's your slope. Okay, m is -2. So now, for my equation, I am going to plug in that slope and one of the points. It doesn't matter which one, I would choose the one with the smaller numbers. Smaller numbers make your life easier. Okay? So y minus y1, I'm going to use the 2 -3 up here. This is the one I'm going to use. Y minus -3 equals my slope, -2, which we found, x minus 2. All right? Now the only thing you would have to do to simplify this and get it in true point slope form is change the double negative to positive here. So this would turn into y plus 3. And that is one of them. All right? So now to get either way, if I want to go from this form to slope intercept or to standard form, the first thing you're going to have to do is distribute. All right, so let's distribute and rewrite it. So it's y plus 3 equals, distribute that -2, so it's -2x plus 4. Okay, right there, -2x plus 4, -2 times -2. Now, to get it from this, let's go slope intercept first. If I want to go to slope intercept, the only thing I'm going to have to do is subtract 3 from both sides. Because then I have y equal -2x plus 1. That's it. All right, now to go the other way, and I really could use my slope-intercept form to get to standard form if I wanted to, because that's what I'm going to do here. If I see that -2x, I know that my x and y have to be on the same side, so I would just add that 2x to the other side, and you get 2x plus y equals 1. Okay, so I would recommend starting with point slope form and then changing it after that. Okay, because it's not too bad once you get one of the forms. So there are your 3 forms for this line that goes through those 2 points. I have slope intercept, point slope, and standard form. Okay? If there is any time in the video you guys need to back up, just ask the sub and she should be able to click back in the video. All right, next example is a brain break. So I want everybody to stand up and stretch, okay, because everybody kind of starts to get a little bit extra blood to their buttocks, okay? So stand up, stretch a little bit, take about 1.5 to 2 minutes, stretch out. All right, so the next thing in linear equations, I'm hoping you guys remember these. You should from geometry because you did these in geometry. So we have parallel and perpendicular lines. All right, so parallel lines. What is special about parallel lines? Well, parallel means they have the same slope. Okay, that's important. Same slope. So that means the variable m is going to be the same if I have a y equals mx plus b. All right, perpendicular. So if you think about what's special about perpendicular lines, well, look which way your arrows are going. All right, this one's going up towards the positive, that one's going down toward the negative. So you know it's going to be opposite slope. If you remember back, it's opposite reciprocal because this is 1/3 and that's third. So these are going to have opposite reciprocal slope. Okay, opposite reciprocal. All right, slope is opposite reciprocal. All right, so that's important when we're trying to find the equations of lines when we're given a line already. Okay, so we want to find the equation in slope-intercept form. Okay, that's important because we need slope-intercept form when we're done. For the line that passes through 3, -2 and is perpendicular to the line whose equation is y equals -5x plus 1. All right, so things that I underlined there, those are important for us to get our final answer. First thing that I'm going to use, though, is the word perpendicular, because what did I say up above? Perpendicular means. Perpendicular is opposite reciprocal. Okay, opposite reciprocal. So that means I need to identify the slope in my equation that I'm given, which is right here, -5. So I'm going to write out the opposite reciprocal slope of that guy right there. So I know that it's -5, so that's going to be 1/5. All right, because I flip it, and it's a negative here, so that means this is going to be a positive. So that's my slope right there. So I have a slope, and I have a point that I also underlined up above. So what form am I probably going to use? Point slope. All right, so let's plug it in. Y plus 2. Okay, that's a double negative here. Be careful with that. That's why I did that right away. Y plus 2. Okay, y plus 2 equals 1/5. That's my slope. X minus 3. All right. Normally, I'd say that that's good enough, but we're specified in the problem that we want it in slope-intercept form. So remember what we've done before. We have to distribute the 1/5 and then rearrange stuff to get that slope-intercept form. Okay? So I have to distribute the 1/5. See if I run out of space here. So y plus 2 equals 1/5 x. 1/5 times the -3, that's just going to stay as -3/5. Okay, last thing we have to do is move the 2 over. That has to move over to the other side, so we subtract 2 from both sides. So a little bit of work up here. You guys probably do have it on your calculator. -3/5 minus 2, so we got to get common denominator. So times 5, this turns into 10/5. So -3/5 minus 10/5, that gives us -13/5. So that's what's going to be our y-intercept. So y equals 1/5 x minus 13/5. That's your final answer. That's slope-intercept. Okay? So more than likely you're going to be given an equation that you're going to use for the new equation here, all right? So really in the old equation, I don't care. I did not even use that +1. The only thing I cared about was the slope. That's what I needed, all right? So in this new equation, the separate one, I don't even care about that -2. I'm not going to use it. The only thing I care about in these is the slope. That's what I need to use to find the new equation. All right, go ahead and see if you can figure this one out. So please pause the video, let kids work through this one. All right, back to this one. When we are doing this, we need to identify if we're doing parallel or perpendicular. This is perpendicular, so we're going to change our slope. We say m equals -1/3. All right, then we're going to plug in our point and our slope to point slope form. So it'd be y minus 5 equals -1/3 x minus 3. All right, and then we need to change this to slope intercept because actually it doesn't specify. So you could leave it like this if you wanted to. This would be an answer. It doesn't specify. Okay, but for those of you guys that went through and changed it to point or to slope intercept, if you did, remember we have to distribute there. So it's y minus 5 equals -1/3 x plus 1. 1/3 times 3 is a 1. And then we add 5. We get y equals -1/3 x plus 6. Then you're done. That's slope intercept form. It doesn't specify, so if I don't ever specify in something, if I don't say which form you need to use, which I don't think I normally do on tests or quizzes, then you can use whatever form you want. Okay? So save some time. Make sure you read directions. All right, so graphing linear inequalities. This is 1.5, so this is the rest of the lesson. So when we're graphing these, so I said earlier in the video, these are the lines where you graph them with either a dashed or solid line and you shade above or below. Okay, reading these. So the first thing you want to do is change it to slope-intercept form. So y equals mx plus b. That's what you want to do first. Now we could graph these with intercepts, but we haven't done it yet, so we're just going to keep it to slope-intercepts, the stuff that we've done before. All right, so looking up here. That one. What are some steps that we need to take to change that to slope-intercept form? Okay. Well, we need to move the x over. We need to get y by itself. So you guys did solve stuff like that on your homework, where it says find the rate of change. You had to solve for y and then find what number was in front of the x. Pretty much what we're doing here, but we're just going to graph it after we're done. All right. So solving for y, we move the x over. So I'll be doing my work down here. Go down a little bit. So -2y is less than -x plus 4. All right? And then there are a couple different ways that you can divide by the -2 here. I would just say divide everything by -2 individually with linear equations. It makes it a little bit easier when you're rewriting it, okay? Because those are going to cancel here. And then remember what you have to do to this guy right here, because I divided everything by a negative. Well, that means that has to flip. Okay, make sure you flip your sign, or make sure you pay attention to see if you have to do it or not. All right, so here we had to. So y is greater than now. So this is like x over 2, which is 1/2 x. Okay, this is how I would rather have you guys write it, as 1/2 x. Just use the numbers and attack the x on the outside. All right, and then 4 over -2, that is a -2. So this is what we're graphing. Okay, if some of you guys might not remember how to graph this, it's okay. I'm going to take a little bit of time here to review it. Okay, so remember y equals mx plus b. The first place you started was the b, or the y-intercept. So here we have a -2. That's where you're going to start. Okay, start here. Remember y-intercept, that's the number on the y-axis. So up here, I'm going to start at a -2 on the y-axis. Okay, which is right there. And then we have a slope of 1/2. All right, so when you think of slope, you think of rise over run. So I have a positive number. So that means it's going to be up here somewhere. It's going to go up and to the right because it's a positive. So rise over run, I'll go up 1, so 1 there, and then over 2. So I'm at this point. And then I keep following that pattern. Up 1 over 2, up 1 over 2, and I'm right there. Okay, so normally you could keep going back this way if you wanted to, just kind of follow that pattern. So your line would go something like this if we were just graphing a normal line. I'm hoping you guys kind of remember that stuff. Okay, but these aren't normal lines, these are inequalities. So we have to pay attention to that inequality sign right there. Okay, right down here. Remember, if you're graphing it on a number line, what happens when it's just a greater than or a less than? It's like a circle, but it's not filled in. So the equivalent of a line to being a circle or not filled in is you're going to have a dashed line, okay? So I would have a dashed line like that. That would be the answer for this one. Well, almost. I'm not done yet, because that's where the inequality comes into play. And also, if you're reading it, remember you read these from left to right, starting with the variable. So this says y is greater than. So greater than means everything above. So that means I have to shade above the line. Okay? So greater than is above. I can also do a checkpoint if I wanted to make sure that I shaded it correctly. So if I am making sure that I shaded this correctly, all right, I shaded everything up here, this area up here. I want to plug in a point that's in that area. 0, 0 is usually the easiest point to plug in. Okay? So if I plug in 0, 0, I can plug it in to my equation down below or up above. Okay? And it should work the same way. It should be true if I shaded it correctly. So if I plug in a 0 up here, so I'll do the work off to the side. So 0 minus 2 times 0 is less than 4. So everything is going to turn into a 0. Is 0 less than 4? Yes. So we did it correct. That's how you check those. You pick a point in the area where you shaded and see if it is true or not, if it follows that inequality. All right, so let's go ahead and do the next one together, and then I'll have you guys do a couple on your own. All right? So graph 2x plus 5y is greater than 10. Remember the first thing that we did, we rearranged this to y equals mx plus b. All right, so that means that negative 2x has to go over. All right, we have 5y is greater than negative 2x plus 10. And now we need to divide everything by 5. Okay, we don't have to flip our signs here because this is positive. That's a positive 5, so we don't need to flip our signs. So if y is greater than negative 2/5 x plus 2, that's what we're graphing. All right, so I start at my negative 2. This is where I'm starting. So that is, or positive 2, sorry. We start at positive 2, which is up here on the y-axis. And then we graph our slope of negative 2/5. So this one is going to be going down because it's negative. It's going to be going down this way. So you think of rise over run, or this you could say fall over run if you wanted to. I go down 2, so this is my negative 2. And I go right 5, we're right there. Okay? And if I kept following that pattern, I'd be kind of off the grid. So I'm just going to follow that pattern in the opposite direction. So 2 and negative 5. We can do it either way. All right? So I have my points written out. And this says y is just greater than. So that means that this is going to be a dashed line. Okay, get rid of my little dashed lines there so they don't take up the problem. It's going to be a dashed line connecting these points. Right there. So a dashed line, and it's greater than, so again it is above. So I don't have 0, 0 in the shaded area, so I can still use 0, 0. I think it's the easiest point to use. But now if I plug in a 0, 0, since it's not in my shaded portion, that would not work. If you checked it. All right, so if I check this, if I plug in a 0, so 2 times 0 plus 5 times 0, is that greater than 10? Well, this would be a 0 plus, that's a 0. So is 0 plus 0 greater than 10? No, it's not. So that means we did it correct because 0 is not in the shaded area. So that means we did it correct by shading away from 0. All right? So those are graphing inequalities. I want you guys to try a couple here. So please pause the video, have students work through these, and then I will show the solutions. All right, for A, graphing that one, solve for y again. So we have 4y is greater than negative x plus 2. Divide by 4, y is greater than negative 1/4 x plus 1/2. Okay, that's what we're graphing. We solve for y there. And I'll solve for y on the bottom one too, just to get them both done at the same time. So y is greater than negative 3x minus 8. That's pretty easy. Okay? So how do I graph that first one? I got to start at 1/2. Okay, that's okay. We can still do that. So 1/2, you're just going to kind of eyeball it. 1/2 is right in there. And then I'm going to go down 1 over 4. So it's going to be a negative. It's going down this way. So down 1 over 4. We're here. And then we can go back the other way. So up 1, back 4. We're right there. And it is going to be a dashed line again. So we're right here. Arrow, arrow. And it says greater than. So greater than means above. We're up here. That is the solution. Okay, let's do the other one down below. Oops, moved everything out of the way. All right, the other one down below. So I'm going to graph that one. I'm starting at negative 8, and I'm kind of off my screen. I'm going to add a couple dots. So I just got to add one dot down here. So this would be my negative 8. All right, and I'm going down 3 over 1. So I need a different graph here, but that's okay. I can go back the other way. So I go 1, 2, 3 over 1, 1, 2, 3 over 1. All right, so it's going to be kind of like this. I'll do another point just so it looks kind of, see if I can hit them. So we're right there at the dashed line. And it says greater than. So this one's a little bit trickier to figure out where greater than is. But if you think about, once you get something that's more vertical like this, think about the X number line. So which area of this is going to be greater than or bigger? So is that way going to be bigger, or is that way going to be bigger? Okay. The right would be bigger, or right is also above here. Okay. So this is the area that we're going to shade. And again, if you're unsure, you can do those checkpoints. So here I can pick 0, 0. And 0, 0 would work here. Okay, 0, 0 would be a point that does work on this one. Okay? So those are the two graphing inequalities. And you might see some word problems. I'm not going to take a whole lot of time to go over a word problem, but you'd have to turn word problems such as this into inequalities. Okay? So usually you're going to have two variables given here. So if you read through this one quick, just kind of browse through it. We've got a tutoring company that's trying to help students to have a combined score on the SAT of 900 or less. And it tells us down here, let X represent the verbal score and Y the math score. All right, so it's a combined score, so it'd be X plus Y must be less than 900. It says 900 or less. So this would be the inequality that I would graph, all right? Now, I don't expect you on these to write 900 little dash marks. If I were doing a graph here, okay, since this is a real-world application, usually you don't need any negatives, okay? But I would say that X is going to be the verbal score, so this is verbal, and Y is going to be the math. So math score there, and I would just say you go by 100s, or you could do 1 on the bottom and 100s on the side, or you could go by 50s if you wanted to, but I would say it's easiest just to go by hundreds. And then you scale it, so you'd have to go up to 900 and graph it. Okay? So hopefully that helps on some of the word problems. I'll be back on Wednesday to work through some of those. But the rest of these are just word problems, so we won't worry about those. So here is your assignment. Take the rest of the time you got to work on that. I do have the answer key, or the book is at the front of the room. I'll leave that up there for when I'm gone. So if you got questions tonight, shoot me an email, and I should be able to answer you through email. So good luck. Have a good one, everybody.